In this lesson, we're going to look at applying exponential growth and decay functions. So we've talked about graphing. Now, if we're trying to apply these in the real world, we'll talk a little bit about different compoundings today, and then we'll talk about compounding continuously, which will be a different day. But today, suppose you invest an amount of money, P, and we call that the principal or the initial amount, which is compounded so many times per year, N, at an annual rate of R, then we say let A be the amount after so many years T. So really all you guys are going to be doing here is plugging things into your calculator. It's just going to be a matter of making sure we know how to do that. So, and we're just going to use the formula that it gives us. So depending on the number of times it's being compounded, that's going to determine your N in your problem. So the number of times it is compounded each year, we've got 6 there. So annually means that we are compounding it. If something happens annually, it means 1 time a year. Monthly, how many months are there in a year? Each month it will get compounded, 12. How many weeks are there in a year? 52. It will get compounded 52 times. Semi-annually means your money would get compounded twice. Quarterly, a quarter is worth 25 cents in a dollar, but how many quarters make up a dollar? 4. Quarterly means 4 times a year. And daily, how many days are there in a year? 365. So using your equation, you might want to jot down what each of them means. We're just going to plug in our values that our equation gives us. So our P is the principal or the starting amount or deposit of money. So however much money you're putting in. A is your end amount. Your rate is R, and that's going to be written as a decimal. So if you're trying to find a decimal, all you guys need to do is take your percent and divide by what? By 100. So if you're trying to get a rate as a percentage, you just divide by 100, or you move that decimal 2 places to the left. So that's your rate. Now the N, the number of times it's being compounded, is actually going to be used twice, in the denominator there and in your exponent. So N is the number of times per year your money is being compounded or earning interest. And then T is your time. So that's the number of years being compounded. So that's the time spent in the account or in the bank or wherever you have that money. So if we look at number 1, it says Jess places $1,000 in a savings account which pays 6% interest. What is the value of the account at the end of 10 years if the interest is compounded semi-annually, monthly, and daily? So it wants us to do it 3 times. So I'll do daily with you guys, and you guys can try semi-annually and monthly. But let's first identify what everything is. So if she's placing $1,000 in the savings account, the $1,000 is going to be what she's depositing, or that start value. 6% is the rate, and that's going to be 0.06 as a decimal. And then it says at the end of 10 years. So 10 is her time, and if I'm doing daily with you, N is going to be 365 times. So we have our P, our A, no, we're trying to find the A. We have our P, our R, our N, and our T. So we're literally going to just plug it in to the value. So if we're trying to find how much C ends with, we're going to do A equals 1,000 times 1 plus, that's always in your equation, the rate, which is 0.06, over the number of times it's going to be compounded, which is 365 to the power of n times t. So 365 times 10. So we just need to make sure we know how to put this into the calculator. So when you're doing, I just need to see the equation and I need to see your answer. So I can, after I write the equation, I can go down right away and write a equals, but we need to type this into the equation or into the calculator first. So the only thing you have to be careful with is your exponent, because 365 times 10 needs to all be up in the exponent. So I'm going to pull my calculator so you can see how I'm typing it. So I'm going to do 1,000 times 1 plus, and now the fraction is just 0.06 divided by 365 to the power of, in parentheses, 365 times 10, close parentheses, and then equals. So we're dealing with money here, guys, so we're just going to make sure that we make this 18.22 and 3 cents. Round to the nearest cent. So for those, you're literally just typing into your calculator once you get all the information. So you guys can go ahead and try this semi-annually and monthly. And I'm actually going to go down here and do number 2 with you because it's a little backwards. It says when she was born, Lucy's grandparents started a savings account for her so that when she became 18, she would end up with or receive $5,000 for college. So if this bank pays 6% interest compounded monthly, how much must her grandparents have initially deposited? So in this case, we're actually trying to find the initial amount, which is P, and we're given A, the end amount. So $5,000 is your A, and we know that the time is 18 because it was from the time she was born till the time she turns 18, so that's your T. And 6% is the rate. So actually, again, rate is 0.06. And it says it's compounded monthly. So monthly is your N. And not 365 months. There are only 12 months. So we can at least plug this in and then we'll go from there on how to solve it. So this time we know that A, or the end amount, is $5,000. We need to find P, but everything else we have. So 1 plus still, and your rate is 0.06 over your N, which is 12 because it's monthly, to the power of 12 times your T, which is 18. So 12 times 18. Okay, so we need to figure out first what this whole thing is equal to. So if we figure out that part, then once we get that value, we'll have P times that value, and we can just divide both sides by what that is to get P. So I'm going to type 1 plus 0.06 divided by 12 to the power of 12 times 18 into my calculator. So 1 plus 0.06 divided by 12 to the power of 12 times 18. So we get about 2.9367. So I'll do 4 decimals, 2.9367. So we have P times that equals 5,000. So all we have to do is divide both sides by that 2.9367. that will go away, and if I go back into my calculator, divided by whatever you guys might answer. So 1702 and 55 cents. So 1702, 55. So sometimes you will need to find A, sometimes you will need to find P, but we did an example of both. If you're trying to find P, you just have to figure out what that big part is first, that value, and then you'll divide both sides by that value. So it's really 2 steps instead of just 1.